Let's talk a little bit more about arrays, and particularly the pros and cons of arrays. Now, arrays in C++ and in most languages look something like this when we go to declare them. And what this does is it creates one contiguous block of memory for us. It's going to allocate in RAM something that's the size of an integer times 5. So if this is a 32-bit integer, it's going to allocate 32 times 5 bits for us. Or if this is an 8-byte integer, it's going to allocate 8 times 5. It's going to allocate 40 bytes of memory for us, right? And it's going to do that one time. So in memory, we're going to have something that looks like this. Here's this giant block of memory, and every 4 bytes or 32 bits or however big an integer is, it's going to essentially splice it up for you and say, here's this huge block of memory that you can use, right? ... and here's the end of it. And you can access these things by doing a brackets 0, a brackets 1, a brackets 2, so on and so forth, right? Now, we've probably already talked about the differences between a pointer and an array in C++, which is nothing. But just to add into that real quick, why are arrays zero-based, zero-index-based? Like, why is the first one 0? Well, it's because the subscript operator is the same thing as using pointer arithmetic and dereferencing this pointer, this variable a. So if we were to dereference a plus the subscript, how many values you want to go over? So a plus 0, that will dereference the position of a, the first position of a, because it's not adding anything to it. A plus 0 is just going to be the position of a, right? So this is the reason why arrays are zero-based, in case anyone ever asks you in the future, right? Cool. So one great thing about arrays is that they are super quick to access these elements, really quick. I know where element 2 is because of that pointer arithmetic that I just did, right? I know element 2 is at a plus 2, and I can dereference that, right? Which is the same thing as doing a brackets 2, right? One is just shorthand for the other, right? And this is really quick. Just an addition, right? A really small multiplication as well to determine the size of an integer, right? But that happens under the hood. And these are both valid lines of code in C++ to jump to that position, right? So arrays are fast. That's one of the great things about them, right? And the main reason why is because it's using this contiguous block of memory. So contiguous blocks of memory allow you to determine exactly where each element is. Now, one downside about arrays. Arrays are a fixed size. So when I declare an array here in code and I say I want my array to be size 5, what happens if I have to put 6 things into it, right? Well, I can't adjust the size of this array once it's been declared. I can't. Arrays are a fixed size. I can't adjust it. So if I need more than 5 elements in there, I'm out of luck. So I need to figure out some other way to do it, right? What we need is a method of dynamic memory allocation, which means that I want to allocate memory dynamically based on my needs as my program is running, which means that I can't really declare arrays in the traditional sense like this, right? This is where the power of pointers and the new operator combined allow you to dynamically allocate memory on the fly, right? Let me show you an example. We know that a, this variable here, is essentially the same thing as a pointer, right? This int star p, I could assign this to a, right? It's literally the same thing. I'm not even using an address to of operator here or anything like that. A is a pointer, right, to this block of memory. Well, if a is a pointer, like, why can't I declare this thing as if it's a pointer, right? I know that there's a new operator that I can use to dynamically create memory on the fly. Well, why can't I create a block of memory on the fly? And the answer is that I can. So to do that, I can do something like this. Instead of saying int a brackets 5, I could do something along these lines. I could say int asterisk a. I have a pointer called a, and I want this to be equal to a new block of memory that's going to hold integers of size 5, right? Slight difference here in what's going on, right? This thing, I've said I want this to be size 5. It's going to give me this block of memory, and then A is essentially acting as a pointer, right? Same deal here. I'm going to initialize this A. I'm going to point it to a new block of memory. This version of the new keyword that takes a subscript operator like this is going to allocate me a block of memory just like it would up here. Here's my block of memory. ... right? Size 5. And A is going to be pointing. It's going to have the memory just at the very beginning of this giant block of memory, right? Now, what happens if I need to store more data in this? Well, now, because I'm using new, I can delete it and I can recreate it. I could do something like this. I could say, you know what? I'm going to call the delete operator. Now, delete has a special version of the operator for when you're using a subscript. Delete a block of memory. I'm going to delete the block of memory at A. This will delete this whole block of memory that's been allocated to me. And then afterwards, I could say A is now equal to a new integer block of size 10. And it's going to create a brand new block for me somewhere else in memory that's brand new, ... that has space for 10 elements. Using this method, using my new operator, using my delete operator, I can dynamically delete my arrays and recreate them at a different size, right? Now, there's a couple complexities to this. One of the complexities is if I had data in my array, if I was storing values in here, I need to somehow manage to copy those over to the new position, right? The other part about this is like, as I'm copying them, I'm going to have 2 blocks of memory, right? Well, with C++, what we should do is we should wrap all of this logic into a brand new class. Let's call it our super array, our better array, our dynamically allocated array. Or let's call it a vector. This is the fundamental concept of what a vector class is in C++. It's a built-in array that can be resized dynamically. It still uses a contiguous block of memory, so it's fast when you go to access it, just like our built-in arrays are. Although it does take up a lot of space, right, as you're copying data, as you're moving data across, right? But this is the fundamental structures on how a vector class is created.